Adventurous kids explore with education and learning what a wildlife is in the Everglades. I want to explore the Museum of Discovering Science. What plants do butterflies like? I want to know about Key West. Adventurous kids, learning and fun. Adventurous kids!
Today we're going to tell you about natural rubber. Natural rubber, also called by other names of India rubber, latex, caoutchouc or caoutchouc, as initially produced, and consists of polymers of the organic compound isoprene with minor impurities of other organic compounds plus water. Thailand and Indonesia are two of the leading rubber producers types of polyisoprene that are used as natural rubbers are classified as elastomers. Currently, rubber is harvested mainly in the form of latex from the rubber tree or others. The latex is sticky, milky colloid drawn off by making incisions in the bark and collecting the fluid in vessels in a process called tapping. The latex then is refined into rubber that is ready for commercial processing. In major areas, latex is allowed to coagulate in the collection coat. The coagulated lumps are collected and processed into dry forms for marketing. Natural rubber is used extensively in many applications and products, either alone or in combination with other materials. In most of its useful forms, it has a large stretch ratio and high resilience and is extremely waterproof. A major commercial source of natural rubber latex is the Amazonian rubber tree. This species is preferred because it grows well under cultivation. Properly managed tree responds to wounding by producing more latex for several years. Congo rubber is formerly a major source of rubber. Dandelion milk contains latex. The latex exhibits the same quality as the natural rubber from rubber trees. Wild types of dandelion latex content is low, varies greatly. In Zazie, Germany, research projects tried to use dandelions as a base for rubber production but failed. The first use of rubber was by the indigenous cultures of Mesoamerica. The earliest archaeological evidence of the use of natural latex from the Hiva tree comes from the Olmec culture, in which rubber was first used for making balls in the Mesoamerican ball game. Rubber was later used by the Maya and Aztec cultures. In addition to making balls, Aztecs used rubber for other purposes, such as making containers and to make textiles waterproof by impregnating them with the latex sap. In the early 1900s, the Congo Free State in Africa was also a significant source of natural rubber latex, mostly gathered by forced labor. In India, commercial cultivation was introduced by British planters, although experimental efforts to grow rubber on a commercial scale were initiated as early as 1873 at the Calcutta Gardens. The first commercial heavier plantations were established at Padu in Kerala in 1902. In later years, the plantation expanded to Karnataka, Tamil Nadu, and the Andaman and Nicobar Islands of India. India today is the world's third largest producer and fourth largest consumer in Singapore. And commercial production was heavily promoted by Henry Nicholas Ridley, who served as the first scientific director of the Singapore Botanic Gardens from 1888 to 1911, distributed rubber seeds to many planters and developed the first technique for tapping trees with latex without causing serious harm to the tree. Because of his promotion of this crop, He is popularly remembered by the nickname Mad Ridley. Rubber exhibits unique physical and chemical properties. Rubber's stress-strain behavior exhibits the Mullen effect and the pain effect, and is often modeled as hyperelastic. Rubber strain crystallizes due to the presence of weak nucleic CH bond in the repeat unit. Natural rubber is susceptible to vulcanization as well as being sensitive to ozone cracking. Two main solvents for rubber are turpentine and naphtha petroleum. Because rubber does not dissolve easily, material is finely divided and shredding prior to immersion. An ammonia solution can be used to prevent coagulation of raw latex. Rubber begins to melt at approximately 356 degrees Fahrenheit. Wow! On a microscope scale, relaxed rubber is a disorganized cluster of radically changing wrinkled chains. In stretched rubber, the chains are almost linear. The restoring force is due to the preponderance of wrinkled deformations over more linear ones. For the quantitative treatment, cooling below the glass transition temperature permits local conformational changes, but a recording is practically impossible because of the larger energy barrier for the considered movement along the chain. Frozen rubber's elasticity is low, and strain results from small changes of bond lengths and angles. This caused the Challenger disaster when American space shuttle's flattened O-rings failed to relax to fill a widening gap. The glass transition is fast and reversible. The force resumes on heating. Rubber latex is extracted from rubber trees. The economic life period of rubber trees in plantations is around 32 years to 7 years of immature phase and about 25 years of productive phase. Soil requirement is well drained. Weathered soil consisting of lateritic types, sedimentary types, materic, red, or alluvial soils. The climatic conditions for optimum growth of rubber are rainfalls around 98 inches, evenly distributed without any marked dry season, and with at least 100 rainy days per year. Temperature of about 68 to 93 degrees Fahrenheit, with a monthly mean of 277 to 82 degrees Fahrenheit. Atmospheric humidity of around 80%, about 2,000 hours of sunshine per year at the rate of 6 hours per day throughout the year. Absence of strong winds. Many high-yielding clones have been developed for the commercial planting. These clones yield more than 1,800 pounds per acre of dry rubber per year under ideal conditions. Places such as Kerala and Sri Lanka, where coconuts are in abundance, half shell of coconut was used as a latex collection container. Glazed pottery or aluminum or plastic cups became more common in Kerala and other countries. The cups are supported by a wire that encircles the tree. This wire incorporates a spring so it can stretch as the tree grows. The latex is led into the cup by a galvanized spout knocked into the bark. Tapping normally takes place early in the morning when the internal pressure of the tree is highest. A good tapper can tap a tree every 20 seconds on a standard half-spiral system. A common daily task size is between 450 and 650 trees. Trees are usually tapped on alternate or third days, although many variations in timing, length, and number of cuts are used. Tappers would make a slash in the bark with a small hatchet. These planting cuts allow latex to flow from ducts located on the exterior or the inner layer of bark cambium of the tree. Since the cambium controls the growth of the tree growth and stops if it is cut. Thus rubber tapping demanded accuracy so that the incisions would not be too many given the size of the tree or too deep, which could stunt its growth or kill it. It is usual to tap a panel at least twice, sometimes 3 times during the tree's life. The economic life of the tree depends on how well the tapping is carried out. As a critical factor is bark consumption. Standard in Malaysia, alternate daily tapping is 25 centimeters vertical bark consumption per year. Latex containing tubes in the bark ascend the spiral to the right. This reason tapping cuts usually ascend to the left. Cut more tubes. Trees drip latex for about 4 hours, tapping as latex coagulates naturally on the tapping cut, thus blocking the latex tubes in the bark. Tappers usually rest and have a meal after finishing their tapping work, then start collecting the liquid feel latex at about midday.
Natural rubber is often vulcanized, a process by which rubber is heated and sulfur peroxide or bisphenol are added to improve resistance and elasticity and to prevent it from perishing. Carbon black is often used as an additive to rubber to improve its strength, especially in vehicle tires, which account for about 70%, 9 million tons of carbon black production. Bang, boy!
Uncured rubber is used for cement, for adhesive, insulating, and friction tapes, and for cheap rubber used in insulating blankets and footwear. Vulcanized rubber has many more applications. Resistance to abrasion makes other kinds of rubber valuable for the threads of vehicle tires and conveyor belts, and makes hard rubber valuable for pump housings and piping used in the handling of abrasive sludge. The flexibility of rubber is appealing in hoses, tires, and rollers for devices ranging from domestic clothes ringers to printing presses. Its elasticity makes it suitable for various kinds of shock absorbers and for specialized machinery. Mountings designed to reduce vibrations. Its relative gas permeability makes it useful to manufacture articles such as air hoses, balloons, and balls and cushions. Resistance of rubber to water and to the action of most fluid chemicals has led to its use in rainwater, diving, and chemical, medicinal tubing, and as a lining for storage tanks, processing equipment, railroad tank cars. Because of their electrical resistance, soft rubber goods are used as insulation and for protective gloves, shoes, and blankets. Rubber is used for articles such as telephone housings, parts for radio sets, meters, and other electrical instruments. Coefficient of friction of rubber, which is high on dry surfaces, low on wet surfaces, leads to its use for power transmission and belting and for water lubricated bearings, deep well pumps. Indian rubber balls or rubber balls are made of rubber.
Around 25 million tons of rubber are produced each year, of which 30% is natural. The remainder is synthetic rubber derived from petrochemical sources. The top end of latex production results in latex products such as surgeon's gloves, balloons, and other relatively high-value products. The mid-range of which comes from the technically specified natural rubber material, comes out largely in tires, but also in conveyor belts, marine products, windshield wipers, and miscellaneous goods.
Thank you for watching
This Adventurous Kids episode.
and
What did you learn today?
Adventurous Kids.
Adventurous kids!
What was the most interesting fact?
Adventurous kids!
Adventurous Kids.
Hey. Adventurous.